Welcome to Global West. Please subscribe and hit the bell icon for more breaking updates. Imagine standing in Yellowstone National Park surrounded by geysers that shoot columns of steam and water high into the air, their eruptions echoing across a landscape shaped by fire and ice. All around you are deep canyons and rushing rivers carving their way through ancient rock. It feels timeless, as if this land has always been here, unchanged. But beneath your feet, something remarkable is happening. The land is slowly, almost imperceptibly, pulling apart. Recent scientific discoveries reveal that the ground to the northeast is creeping in one direction, while the southwest shifts in the opposite way. These movements are subtle, but, over time, they reshape the very face of Yellowstone. This isn't the park splitting in two overnight, but rather it's evidence of immense geological forces at work. Forces that have been shaping Yellowstone for millions of years, sculpting its cliffs, valleys, and unique rock formations. You can't see or feel this movement with your senses alone. It's measured in millimeters per year, detected only with the help of precise GPS technology and sensitive instruments placed throughout the park. Yellowstone sits in a dynamic zone where the Earth's crust is being stretched and pulled apart. This ongoing process has created the region's dramatic mountains, sweeping valleys, and broad basins, giving Yellowstone its breathtaking scenery. By studying this slow but powerful movement, scientists can piece together the park's ancient past, how it was formed, how it has changed, and even make predictions about its future evolution. While bison graze peacefully and geysers erupt in spectacular displays, a deeper, hidden drama is always unfolding. The very foundation of the park is being stretched, compressed, and molded by forces deep within the earth, shaping the land in ways we are only beginning to understand. In this chapter, we'll explore what causes this extraordinary phenomenon, from the relentless stretching of tectonic plates to the powerful influence of volcanic activity, and discover how scientists track these subtle but significant changes over time. Join us on a journey into the hidden mechanics of one of Earth's most extraordinary places, where the ground beneath your feet is alive with motion and possibility. The ground beneath Yellowstone is never truly still. Let's uncover the secrets of why this land is always in motion, and what it means for the future of this remarkable park. Yellowstone's Great Divide is driven by powerful tectonic stretching, a force that has shaped the region for millions of years and continues to do so today. This process is literally pulling the western United States apart, stretching the land like taffy and creating dramatic changes in the landscape over time. The Basin and Range Province, which extends from California all the way to Utah, is a vast region where the Earth's crust is slowly thinning, cracking, and sinking, forming a patchwork of valleys and mountain ranges. These changes aren't caused by Yellowstone's volcano itself, but by the massive, slow-motion movements of tectonic plates deep beneath the surface. As the crust stretches and thins, it buckles and breaks, giving rise to towering mountain ranges and deep valleys that define the region's rugged beauty. The stress from this stretching builds up over decades or even centuries, until it finally snaps along faults, unleashing earthquakes that can reshape the land in an instant. Most of the thousands of earthquakes that shake Yellowstone every year are actually caused by this relentless tectonic stretching, not by volcanic eruptions as many might assume. The movement is incredibly slow, just a few millimeters per year, but over thousands or millions of years it transforms the landscape, carving new features and erasing old ones. The 1959 Hebgen Lake earthquake, a magnitude 7.3 event, was a dramatic and deadly reminder of the immense power locked within these tectonic forces, leaving behind scars that are still visible today. In the grand scheme, Yellowstone's volcano is just a passenger on this tectonic conveyor belt, riding atop the restless forces that make this region one of the most dynamic and ever-changing places on Earth. Beneath Yellowstone, another force pulses, the Yellowstone hotspot, a plume of molten rock rising from deep within the Earth. This hotspot has fueled super eruptions, the last one forming the Yellowstone caldera 631,000 years ago. The caldera's vast magma chamber powers the park's geysers and hot springs. As magma and fluids shift underground, the ground above rises or sinks, like the volcano's slow, steady breathing. Between 2004 and 2010, the caldera floor rose up to 7 centimeters per year, then began to subside. These cycles of uplift and subsidence are normal, not signs of imminent eruption. The interplay of tectonic stretching and volcanic activity makes Yellowstone one of the world's most dynamic landscapes. This constant change fuels the park's wonders and reminds us that creation is ongoing. Detecting Yellowstone's subtle ground movements requires cutting-edge technology. Scientists use a network of high-precision GPS stations anchored across the park, tracking shifts as small as a fraction of an inch. This network revealed the opposing movement on either side of the caldera. To isolate local changes, scientists subtract the overall motion of the North American plate. Satellite-based INSAR provides a broad view, mapping uplift and subsidence across the park. Together, GPS and INSAR offer an unprecedented look at Yellowstone's dynamic crust. Constant monitoring helps scientists distinguish between normal activity and signs of change. This vigilance ensures timely information for both the public and park managers. Yellowstone's underground forces reveal themselves in dramatic ways. Earthquakes are common, up to 3,000 a year, most too small to feel, but a constant reminder of tectonic stress. Occasionally, larger quakes, like the 2014 magnitude 4.8 near Norris Geyser Basin, provide a tangible jolt and can even trigger ground uplift. Hydrothermal explosions are another spectacle, as superheated water suddenly turns to steam, hurling rocks and mud. A recent explosion at Biscuit Basin led to area closures, showing how quickly conditions can change. These events aren't signs of impending eruption but normal behavior in a geologically active region. Earthquakes and steam vents are pressure release valves, shaping Yellowstone's ever-changing landscape. Each event tells part of the story of the forces at work beneath the park. Yellowstone's geysers, over half the world's total, are powered by heat from the magma chamber deep beneath the park. This immense heat source is what drives the spectacular eruptions that draw millions of visitors each year. And water from rain and snow. These waters seep into the ground where they are heated by the magma and eventually forced back to the surface. Tectonic stretching creates fractures that act as natural plumbing, allowing water to travel deep into the earth and return as steam, letting superheated water rise and erupt as steam. These eruptions can be both predictable and unpredictable, adding to their mystique. This system is sensitive, even tiny earthquakes can change geyser behavior, altering the timing and intensity of eruptions by opening or closing underground pathways. These pathways are crucial for the movement of water and steam. Steamboat Geyser, the world's tallest, can go quiet for years, lying dormant and seemingly inactive, then suddenly erupt frequently, often linked to subtle ground shifts. These shifts can be caused by minor seismic activity or changes in underground water flow. Yellowstone's ground is almost always vibrating, a testament to the park's dynamic geological activity, with up to 3,000 tremors a year. These tremors range from tiny, barely noticeable quakes to more significant seismic events. Scientists track these quakes to distinguish between tectonic and volcanic causes, helping them understand the underlying processes, a crucial part of monitoring the park's health. This ongoing research is vital for predicting potential hazards and ensuring visitor safety. Watching both geysers and earthquakes gives a fuller picture of Yellowstone's dynamic forces. This dual approach allows for a more comprehensive understanding of the park's geothermal and seismic activity. Changes in hydrothermal activity or seismicity can signal shifts deep below. These shifts can indicate changes in the magma chamber or the movement of underground water. Constant vigilance ensures any unusual activity is quickly detected and understood. This vigilance is key to maintaining the safety and natural beauty of Yellowstone. Yellowstone's constant motion might sound alarming, but it's actually what makes the park safe. Thanks to round-the-clock monitoring, scientists know Yellowstone's every move. The volcano alert level is green, normal, and all activity is within expected ranges. The chance of a major eruption is extremely low, far less than many other natural disasters. The real value of monitoring is early detection of any unusual changes, long before they become dangerous. If warning signs appeared, the Yellowstone Volcano Observatory would alert the public in plenty of time. Science turns Yellowstone into a living laboratory, letting us appreciate its wonders with awe, not fear. With vigilant monitoring and transparent communication, Yellowstone remains safe for millions of visitors each year.